Okay, in the interest of time, I am just going to get things moving. So good morning, everybody. My name is Nicola Taylor. I'm COO here at ScotlandIS. For those of you who don't know, we're the trade body and cluster management organisation for the digital tech sector here in Scotland. Now, last September, we launched a series of ScotlandIS Tech Tidbits. They take place on the first Tuesday of every month. They start promptly at 11:30 and last around 30 minutes. These sessions are designed to educate you in areas that you want to know more about, encourage you to innovate with your newfound knowledge, and potentially collaborate with the speakers and hosts. I would ask that any questions you have be placed in the chat box, and then we will ask these at the end of the presentation. I would also ask that you please keep your cameras off and place yourself on mute for the duration of the presentation. Today, I am delighted to be joined by Dr. David Bell, Product Manager at Bellrock Technology. And this session will cover how can we overcome fundamental challenges to unblock the true value of AI and data in business. So without further ado, over to you, David.
Thanks, Nicola. I'll share the slides. And can everyone see these okay? Perfect. So thank you very much. So today I'm going to talk a little bit about how to unblock data and AI across your organisation. AI is obviously becoming a really hot topic at the moment, which is exciting for me. But one of the big things is the challenge between building different proof of concepts and prototypes and actually operationalising that and getting the value from your business is still quite wide. So what we want to focus on today is how do we actually make a lot of this real? So very quick introduction to myself. So again, I'm David Bell. So I've worked in AI for around 20 years now. Did a PhD in artificial intelligence back in 2006, but my career is often driven by impact. I think that's always excited me and pushed me forward is how do you make these tools real and actually change things for organizations? So when I was doing my PhD, it was very computer sciencey. It was building AI decision-making tools for robotics, incredibly exciting. End of the day, you kind of wrote a big book, put it on a shelf and didn't really do much with it. I moved into engineering, thinking we'll be working with real data, real stakeholders, real problems, which was mostly true. But again, there's still that challenge of, okay, we've built something really interesting. How do we get it over to those stakeholders' hands? Was still huge. And most of those projects didn't go that far. So I ended up leaving academia, and this segues nicely into where I am just now, and joining a company called Bellrock Technology. And Bellrock Technology has been going for 12 years and has been all around how do you take those AI innovations, machine learning tools, and how do you get them into production? How do you make it easier for all these teams across companies to actually operationalize and use these tools? So it's been a perfect fit. I've now been there with tech for the last 10 years, probably because it's been such a good match of purposes. And what we've done is built a tool called DeckShare, which is a platform to make it really easy to take AI, take machine learning, take innovation, and allow teams of data scientists or intelligent users or data practitioners to build end-to-end data products in minutes. But the real crux of this is why I'm here is just that I've spent the last 20 years of my life looking at how AI can impact organizations and how you get it into people's hands. So I want to talk a bit about that today. So one of my starting points is just to really quickly define what we mean by AI. So one of the most exciting things for me is having been working in this area for so long is AI has now came to the forefront of a lot of conversations, which is amazing. The downside is AI is getting quite synonymous with generative AI, and a lot of people are starting to see that they're just a one-to-one mapping. And generative AI is amazing. It's one of the most exciting developments in recent times. But for what we're talking about, AI encompasses much more than that. AI encompasses all the kind of tools, machine learning, ways of using your data to predict future results, future problems, future outcomes, classifying your data to understand different ways things are operating, different way people are behaving, different way assets are working. Things like deep learning, where you're using image analysis to identify challenges within images or make more intelligent decisions, and generative AI itself, including things like building chatbots, creating images, creating coding. And AI goes beyond even these. AI is looking at automation. How do you actually automate a process? How do you replicate that process repeatedly? How do you use intelligent systems, expert systems, rule-based systems? It encompasses all of this. So, but it's just to broaden that scope, just simply because we will be spending a lot of time talking about this, and it is the wide variety of the different AI tools that are out there in the landscape. So why do we want to block on AI, or why do we need to unblock AI? One of the big things is AI just now, being in this hype cycle, being this kind of current hot topic, is driving innovation across companies just now at an accelerated rate. People are now starting to see how they can actually really impact their organization. And because they're seeing so many stories about this, starting to feel left out if they're not using AI. So this is causing a complete rush of people to look at how can they use AI within their business. And that's amazing. I mean, AI can enable absolutely amazing outcomes. You can now start to automate really complex processes. And with AI, you've always got to do some form of automation, but with things like generative AI, you can do some really amazing, sophisticated tools that can free up hours of human time and allow people to focus on more complex tasks while using AI to automate some of the more mundane. AI is opening up entirely new revenue streams for companies at the moment, where they can start to build new AI-enabled products, where they can actually start to gain real efficiencies in their processes, lower costs, or find new customers quicker than ever before. So this is powering a whole wave of new innovation, interest, excitement. But what we're seeing is there's still this massive chasm between what people are looking at and what people are doing and the kind of tools that they're playing with and building, and what's actually making it into business as usual. It's really easy to do a proof of concept. It's really easy to get something up and running which is interesting, exciting, but it's really hard to get that into business as usual, where it's running in an operation, people are actually interacting with it and getting the value from it. And again, as somebody who's been driven by impact, one of my big frustrations is seeing these tools sit in the vine and not actually have the potential that they should. You know, the people are not using these tools to change their organization, to drive change, to improve their enhancements, to improve and enhance their business. They're just sitting there. And then they'll move on to the next POC and then move on to the next POC and nothing changes. So this is why we really want to fix this. And this is why I kind of, again, one of my big things I really want to evangelize is how you can actually change all of this and actually get these things into people's hands. So I want to touch on why this is a problem. And again, one of the big ones for me is things like data. Data is one of the biggest challenges in our organization. It's the key to using any AI, whether it's generative AI or machine learning. Having good quality data is one of the most fundamental aspects. And in most organizations, data is pretty siloed. Finance departments will have their finance tools, sales will have their CRMs, engineering will have their different asset management tools, product will use things like Jira and software development tools. And all these organization structures grow, create their own tools and their own data, and then none of it interacts. So one of the big challenges, if you want to build a sophisticated tool that can start to answer questions on your business or start to generate reports or proposals or any of these things, is it can't access 90% of your data because it's all in different places. Data quality is also a massive challenge where most data in companies is not amazing. Having worked with such a wide variety of companies from such a wide variety of industries, the one thing I can say with some certainty is nearly every company's data is kind of terrible, and that's okay. But it does need to be addressed to get the most value out of your investment in AI. The other big one we see all the time is the misalignment between business goals and AI. So people get very excited, people want to try new things, people will be looking to solve their own problems, and all of these things are great. But quite often, when you're investing all that time into building a POC, if it's not actually aligning with the strategy of the business and what it's trying to do, when it comes to funding it to go from that POC to product, all of a sudden you might not have the buy-in from the upper management, the leadership team, the stakeholders, basically people holding the purse strings. So we need to make sure these new POCs, these new products actually are pushing the business forward in some fundamental way that everyone cares, that everyone wants to drive it to that end goal, and it doesn't become a pet project. After that, one of the biggest challenges is infrastructure and resources. Do you have the tools to actually support all these models? Can you put them somewhere? Can you connect them to your data? Can you run them and give them all the resources? And do you have a team of people who can actually handle all this? Do you have experts who can work with the data and actually run those models and make sure they're actually safe and secure and all of those things? And once you have all that infrastructure in place, do you have the processes to actually make sure that you can smoothly go from prototype to product without massive amounts of friction? And one of those such processes is what we'd call the data science or analytics lifecycle. So this is a fairly standard diagram you'll see in almost any talks on analytics or machine learning or AI, but it's really important of how to make all of this work. So when we kind of look at this, the first thing you do is identify an application. And this goes back to trying to identify something that strategically aligns with the business that you think AI can help. Once you do that, you can start to look at training data. What data is available in the business to actually build some of these tools. Once you get the data, you go into the analysis and cleansing component, and this is the part that all data scientists hate, but consumes far more time than anyone wants, which is how do you actually make sure that data is fit for purpose? As mentioned, most companies' data is never that good, but that's okay, because that's one of the key things that as a data scientist you need to work with. So you look at how you cleanse it and make it fit for purpose and ready to go. And then you get to the fun part of building the model. This could be building something using generative AI, this could be building some machine learning, this could be building some standard tooling, automation, but you're building something that actually gives some insights, gives some results, gives something impactful back. And this is where most teams focus, this kind of top bit, and this is where you create your POC. You kind of identify an application, go through this process, and you come out with something that's really interesting that you think, okay, this can really change things. But then you're kind of left with something that sits on your computer or sits in a cloud server and doesn't actually interact with anything else in the business. And that's why this back part is so critical. This is then, okay, what do you do with it? Where does it host that model? This needs to live somewhere for its duration of its lifetime. It needs to have the resources to run. It needs to be ready to go. And you need people to be able to handle how you put it there and make it run. And then it needs to be integrated in with all your data. So it needs to flow and connect to different data sources. It needs to run. Those data sources need to be orchestrated to push that data into that model. And the results need to come out and be captured somewhere. And then finally, you kind of want to evaluate this model in anger. And this is all separate from the data science evaluation, where you're looking at confusion matrices and Z-scores and all those fun things to show the model's good. This is more evaluating as in giving a couple of people access to it and saying, does this help? Does this actually move the needle? Does this actually improve our business or operations or insights? And if not, you go around the cycle. And if it does, you put it into operational use. But this cycle is so important because this should be an iterative process. Data science and analytics and AI never go that smoothly, and that's okay. So there is some element of trying it, iterating it, improving it, getting that feedback, and having that for loop. But it's really important to have that loop. So if you don't, again, back to some of the things we talked about, getting funding to have that top half done, to do that POC, can be quite easy. POCs are generally quite cheap. They can be 15,000, 20,000. They can be free if it's just something doing your own thing. And that can be quite simple. But if you've not got that back part in place, the deployment, integration, evaluation, then what we find is quite often one of the biggest hurdles is trying to get the finance internally to push that through. It can be massively prohibitive. That's where you start to need teams of IT specialists. That's where you start to need data teams. That's where you need to start having infrastructure costs if you don't have it in place, which can turn your very cheap POC into a very expensive to produce product. And if it's not got that very clear return on investment, if it's not very, very clearly aligned with the strategic goals, then all of a sudden that becomes something that nobody can sign off on. And what we've saw, I mean, the reports are something like 70% of data products never make it into production. And it's not having this back part fully fleshed out that's kind of the big cause for that. The other big thing is part of this is integration is the difference between trying to get a batch of data to build a prototype versus getting a live feed of data that can be securely integrated and run in real time. Wild gap between those two requests, which again, something that gets blocked. So one of the biggest things I would say from this talk is if there's one big takeaway is really at the start of any project you're doing, any data science project, any AI project, think about where it's going to live at the end. Think about where actually, once we've built this product, where are you going to host it? How's it going to access real data? Who's going to tell you if it's actually good enough or if it's fit for purpose or it's really driving that change? And build that into the start of the project and not the end. Because that's where we see the biggest challenge is people trying to do this at the end of the life cycle of the first POC and just hitting so much friction. But if you do it up front, you at least have a clear path to that end goal. You can make sure you've got the buy-in, the resources, the infrastructure, and it can be a lot smoother process. And that's kind of one of the key things I would really, really emphasize for this. The other couple of things we can start to talk about is just how you actually, just some of the other blockers and how you can remove them. And the first one is making sure you have that solid data foundation, making sure you've got the data to actually power all of your analytics and AI projects. And one of the first things I'd recommend doing for any company, whether they're large or small, it's obviously much more difficult if you're large, but it's a data audit. Have a look at the data you guys are collecting and what it's used for. What are all the different data that's being processed in your organization? Is it coming from different systems? Is there databases? Where's it been generated from? And just almost starting to create that data catalog of what are we generating, what's its purpose, where does it live, and how do you access it? That means when you actually come to doing POCs or AI projects, it becomes much easier to understand where that data is and how you use it and who you need to talk to get access to it. And that unblocks a lot of these things before they even start. Next one is data quality. So again, data quality is terrible, that's absolutely fine. But the big mantra in AI is always garbage in, garbage out. If you try and build a model, and again, it can be a chatbot or a prediction model with bad data, you'll get bad answers. You'll get bad predictions, bad responses, bad conversations. So you kind of need to look in how do we fix that at the source? And a lot of that is just simple of starting to put in checks and balances straight away. Look at little rules you put in your data to make sure that actually can you put some guardrails to ensure that ages aren't above 110, that genders are limited to the ones that you select, and all these different things you can kind of look at and say, we have set data, we know what it's going to be, select from this list. And the other big one is try and remove any human input. So trying to minimize free text, anything handwriting, anything that relies on humans to enter manually, and try and automate as much of that as possible, or at least put in, again, check boxes or drop downs, and you can start to standardize your data really quickly. Data fitness is just making sure it's actually suitable. Like, are you collecting the right data? Is it actually purposeful? Does it actually tell you what you want to know? So, for example, is this actually, if you're monitoring, for example, asset, something that's generating power, is it worthwhile? Are you collecting all the information you need to do something useful with that? Is there anything missing? Is it complete and therefore actually usable? And kind of looking at some of these things. And then centralization is a big one. The kind of theory in data just now is you bring all your data together into a data lake, and that stores all your raw data, and you can basically just dump it in as free as you want. Then you start to organize it, pull it out, put it into a data warehouse, and then from your data warehouse, you have lovely, clean, tabular data, and from that, you can build all your analytics. For most companies, that's overkill. Centralizing your data is really important. Doing that whole approach can be incredibly expensive and have very little return on investment. So starting to look at, how do I bring my key data sources together? How do I bring the key things that I kind of want to use to power my first wave of analytics? How can I combine those is really important. Our next one, again, just to re-emphasize something we talked about, but is really getting in, starting with aligning people in your team and working in an agile fashion. So getting key stakeholders together is really critical, and looking at how do you actually get everyone on the same side to kick off these meetings. Do you have buy-in from the people who are likely to be funding this going forward? Are they involved in the meetings? Can you get everyone as required? So a great one that we've saw go wrong multiple times is if you need data teams or IT teams to deploy this, bring them in early, get them involved at the start, and that means they can start to identify working roadblocks before it gets to the end. One of the biggest blockers we've saw is poor IT or data people thrown in at the last minute of a 6-month project and then asked if they can get this up and running and what the timeline is. At that point, they have no idea what the project is. They feel like they're being backed into a corner, and they probably have a backlog of their own work, and they can start to get quite blocking with that as opposed to supporting. So trying to get people together early, set that return on investment, ensure that actually you can say that this is going to have a real impact on the company, and then people will be very supportive. The thing we've saw with generative AI is it's such a massive return on investment if you're automating a process that you can put human hours on, that it really just opens the doors for people to try and push that through as opposed to block it. The other big thing is defining these success metrics up front, ensuring that actually you understand what does it look like if this goes well. That's one of the key things, because it actually can start to build support. If you're showing these metrics and you're showing you're getting closer to them, you're showing that this model's having an impact, it starts to build up confidence in the project, it starts to build up confidence in using AI and machine learning across the organization, and it starts to really show that things are moving forward. And again, that gets momentum, which is huge. Working in an agile fashion, again, back to what we're talking about in that cycle, data science is not a linear path. Very rarely is it something as simple as I'm going to build this model and it just works. Quite often you have to try different approaches, you'll find roadblocks, bits of the data will be worse than you thought, you'll have to go back to the start. And all that's normal. But if you start to build that in where you're doing these kind of couple of week iterations where you're trying to show value in that period of time, trying to bring people along for that journey, having the kind of communication with the stakeholders, then all of a sudden it becomes something that people can see the progress and get quite excited about. And the final part of that is all bringing it in together as a full team. So again, trying to make sure that the people are constantly meeting throughout that project, whether that's engineering, AI, product, marketing, it doesn't matter. If they're involved in the project, if they're a stakeholder in the project, try and get representative. The other thing we saw go wrong so often is data teams running off, speaking to somebody about a problem, spending the next 3 months building a solution and never speaking to that customer again, and then coming back and doing a big review. If that big reveal doesn't land correctly, then what you find happens is the customer gets their back up, gets upset, it's not right, everyone feels like they waste a lot of time and money, and again, it'll just kill that proof of concept really quickly without actually delivering anything. So by working with the people, by making sure you're having regular meetings, by involving in that iterative development, it keeps the support high, it gets enthusiasm high, and it really helps you get those things over the line and making sure you're on track. And kind of the last big thing is the infrastructure. It's the path to production. This is how you actually get all of this up and running. So there's multiple ways of doing this, and I've just tried to put it into three here. The first one is building everything yourself. So this is when you take some cloud servers and you build all the code, all the databases, all the orchestration, all the tooling. This is something I would almost recommend no one does unless they're a massive IT team or this is critical to your business. This is the type of thing that requires a full development team of back-end developers, front-end developers, network engineers, database engineers, DevOps, all these really high-skilled, high-expense people to build and maintain all of this. The good thing is it gives massive amounts of control, so you can customize it to be whatever you want. The challenge is, again, that's a high cost to get started, and that cost is maintained throughout the lifetime of it because you'll typically need a lot of very sophisticated and talented people to run that throughout the entire time you're running. So again, only if that's something that's critical to your business. The more standard approach, especially for SMEs, or actually beyond SMEs, is just utilizing what cloud providers are creating. So people like Google, Azure, Amazon, all have some amazing cloud services you can start to tie together. So you can spin up a cloud database, you can spin up a cloud model deployment tool, you can spin up a front-end tool that's will visualize your results, and you can start to stitch these things together, orchestrate them, and scale. So this is probably the most standard way of doing things at the moment. It still requires quite a large team, but this time it's more of a data team than an IT team. So these are people who will be like your data engineers, your model ops people, a couple of system engineers, but they'll kind of stitch all these tools together, build all these pipelines of analysis, and allow the data scientists to deploy their models using that. So it can really reduce the operational burden. You're not having to start from scratch. It gets you there a lot faster, but it does still kind of quite high cost as you scale. And typically, one of the big constraints is there will be a vendor lock-in. So all these cloud organizations will try and get you locked into their services and stay there. The final approach is more relatively recent, but it's looking to leverage some of the software as a service or platform as a service tools that are out there. And these are kind of tools designed to challenge all the major pain points of getting data products up and running and into people's hands. So they'll typically be cloud-based and they will allow you to connect your data, deploy your models, visualize the results, and sometimes even code on them and use some of them to build their own tools using drag and drop machine learning. So this is actually the space we play in. So there's a couple of good tools here. There's things like Databricks and Dataiku, which are large-scale big products that kind of try to do everything. And they're really good. They allow you to actually do a lot of this. But it's also where our platform Detio works, where we want to be able to empower data scientists to build an end-to-end product in minutes, really fast and a really efficient and reasonable approach of doing it. So these ones need less data teams. You might have a couple of data engineers for bringing your data out of the different databases into those tools. But then the real thing is the empowered data scientists to handle that deployment and handle that visualization, reducing the need for a lot of the other support roles around that. Their big benefit is to allow you to really rapidly develop tools, data tools, and get them to market, get them into your customers' hands, and get them to people to use. Their drawback is you are less flexible. So again, you kind of have to work within the constraints of those tools. So there is some compromises that need to be made. But if your product can accept those compromises, then they're one of the best ways of getting those tools into people's hands. So just to wrap up, one of the big things we would say is tackle data quality first. This is one of the biggest things that can really kill a POC is building it on bad data. It will just produce bad results and in turn sink it before it gets started. The other big one is aligning any of the AI initiatives with measurable business goals and making sure that what you're building is what the business needs, what people are supporting, what's going to actually get investment, and ensure that actually that you set yourself up for success before you start. Looking at the infrastructure is really key. Look at the people you have in your organization, the people you want to hire. If you're looking to build large data teams, then using that cloud resources is a really good way of doing it, giving you maximum flexibility. If you're wanting to start to build tools internally or for external customers, and you don't have those data teams and you want to move faster, then using some of the SaaS products can get you there much quicker at a much lower cost. Big one we'd always say is start small and iterate. Just start to build these projects up and start to demonstrate the value piece by piece. And my main takeaway for everyone, regardless, is think about the production from the start. Look at how this model is going to live and grow throughout your organization and build from that point. So thank you very much. I think I've ran slightly over, but very happy to answer any questions or any chat.
Thank you very much, David. You're just in time to give us one question, which is fantastic because we've got a question here from Leslie, and she is asking, do you have any examples of moving tools from POC into production?
Yes, so it's something we've done a lot, both at my academic years and commercial ones. So the big one recently is we've been working with EDF Energy, and their R&D team built a tool to try and look at images coming out of the reactors and trying to understand the current state of them. Really interesting tool, built really sophisticated image analysis, really impactful for the organization to try and maintain the life of these reactors. And with our tool, we worked with that team to go from a small POC that they ran, that they could put in front of some very select users to get the feedback. And then we deployed it with them so they could actually go across to all the kind of key members of the monitoring and teams across those reactors and start to be used for proving the safety of them and really kind of driving that forward. And that was something that took, I think from the moment they finished, it was just 4 weeks with various iterations to get that up and running into actual production. And people then start to use that image analysis tool in anger. Why that's exciting to me is EDF's a massive company and doesn't move fast.
Yep.
So it's amazing to see some of these go and actually get into use by the engineers.
Yeah, fantastic. Now, we're almost out of time, but I think we can squash in just one last question, if that's okay with you, David.
Yeah, of course.
So the question here is, what are the biggest challenges when it comes to educating teams on suitable AI use cases and ensuring sufficient transparency on the model's decision-making?
So the biggest challenges for educating teams, I guess, is always that cultural piece. It's trying to get them to buy in that this is something that's going to help them. This is why the start small and iterate is such an important thing for me, is because you start to win people over and take away some of that fear. If people can see it's actually impacting them and helping their jobs, helping their lives, they start to get more excited. And using those use cases as leverage to show the art of the possible can get people to be really enthusiastic about what can be done.
Yeah.
Transparency is one of the biggest ones. That's also why I'm always hesitant when people come with technology first. So a few years ago, a great one is everyone wanted deep learning, neural nets, real exciting, can solve all your problems. But for a lot of companies, they're a total black hole. Like your data goes in, results come out, and there's no way of looking into that. And it's why trying to build transparent models that can give the reasoning of why they made a decision, builds confidence in the model, actually allows you to audit the decision making so that if you disagree with it, you can see why. And you can also then put it into production in some higher regulated use cases. So for us, the real thing there is just choosing the right tool for the box. Things like decision trees or random forests even, or various other ones can have that auditability baked in. And there's also a whole new field of transparent AI of looking at tools without going too technical, but things like Shapley values and Lime, I believe it's called, which can peek inside neural nets and start to actually extract what bits are making the decisions. So you can do these things to really give trust in what the model's doing, understand why it's made its decision, and use that to really help elevate that transparency across the organisation.
Wonderful. Thank you, David. Unfortunately, that is us now out of time for today's session, but David has very kindly offered to answer any questions that we haven't been able to kind of get to today directly. So my colleague has popped in my email address and her own email address. So if anybody wants to reach out with questions, we can certainly pass them on to David, who has kindly said he will answer those for us, and we'll come back to you. Thank you very much, David. That was a really, really insightful session. I think the kind of two things that stood out for me particularly were around the importance of ensuring good data quality and bringing people on that journey with you, kind of getting them in from the get-go so that everybody is bought in and invested in that journey all at the same time. Thank you everybody for joining us. The session has been recorded. We will share it once it's available to stream for everybody. And yeah, thank you very much for taking the time. Great session, David.
Thank you very much.
Thank you.